Hello friends, and welcome to part 2 of ESP-IDF Basics video series. In the last video, we installed and configured ESP-IDF within a Debian virtual machine for use by a Windows host. In this video, we build on that. We'll first cover streamlining SSH with key configuration for MobaXterm and VS Code. Next, we'll move on to actually plugging in the device and flashing a boilerplate app from the ESP-IDF examples. Finally, we'll finish up with some housekeeping on your Debian VM. In the last video, we installed and configured MobaXterm so that we can use SSH to remote control our Debian ESP dev VM. Now, we will further configure this SSH connection to use authorization keys for better security and potentially eliminating the need for passwords. MobaXterm has some built-in tools for generating SSH keys. However, we use the regular command line SSH key generators that come with Windows 10, and we do this because VS Code is going to have an easier time finding it if we do it this way. Let's go ahead and open a command prompt so we can get this started. Type in cmd, you don't need admin access, and type ssh-keygen. What this is going to do is it is going to generate the public-private key pair on your behalf for SSH. For this example, we elect to not protect the SSH keys with a password. Instead, we're going to rely on the OS to keep the keys safe. For purposes of private development on one's own machine, you're probably fine doing this. Key security management is its own topic, and it's worth exploring. OS protected keys may not be sufficient for some, but once again, for this example, it's fine. So we're going to hit enter here, and then enter again, enter again. So it has now generated the keys, and if you're curious, it's in this folder right here. There they are. Now with the keys generated, we move on to configuring Debian. Since the S in SSH stands for secure, we're going to take extra care while we do this. Since this is a video about development and not IT admin, we're going to try to move through this pretty quickly. So let's connect up to our Debian machine. Let's go ahead and use MobaXterm for that like we configured last time. Go ahead and connect up to your Debian ESP. It's going to prompt you for your password. Hopefully you've got a good one like I kept harping on last time about. For the record, I changed the terrible one I used from last session. And now we're where we need to be. And our next step is, seeing that we're at the home directory, we're going to type this. We're going to type makedir.ssh. So as you might glean, that is where SSH is going to keep its metadata. Then we're going to change mode, so chmod 700.ssh. And a long story short, that gives pretty much you and only you OS level access to that folder. I'm going to go into that folder and it'll be empty, and because we can, we will use Featherpad and we will make what we call the authorized keys file. I'm going to put an ampersand here. You don't have to do that. At this point, we're ready to scoop up the key material that we generated in our Windows command box a moment ago. And importantly, we only are interested in scooping up the public key portion. In a private public key pair, the private key is true to its word. You want to keep it private and secure only to your computer. Or even more secure if you have a secure token or something like that. So we'll go back to the command box down here. You're going to use Notepad to open up your idrsa.pub. That's the default name for your public key portion. And you're going to just copy this whole thing. You're going to paste it in to your authorized keys. Word wrap is fine. Don't be thrown off by that. And this permits whoever's got the private key to log in by virtue of this public key being present. So we're going to close that, and we'll close that too. Go back to your Debian SSH session, And now what we're going to do is we're going to change the mode of that authorized keys file to 600. And that is more or less the same permissions as the parent directory. It only gives you OS level access to that file. And don't be thrown off by all these other things. You probably don't have that on yours. Now the final step to getting MobaXterm end-to-end playing with all this is we have to configure MobaXterm to be aware of those secure shell keys. So we go down here into the configuration. You click on the SSH tab up here. You're going to click Use Internal SSH Agent. You hit the plus key. And if you're lucky, it'll be right here at the correct directory that you just generated in your DOS box. And if you didn't find yourself landing here, just manually navigate up here until it matches what you see over here. And what you want to do is you want to grab ID_RSA, not the pub. MobaXterm needs the private key portion, and that's what that is. Hit OK. It'll ask to restart. Click yes. And if all goes well, now when you click on your user session, you see how it just blew by with the authorized keys? Just logged you right in. No password required. Arguably more secure than using a password. We are now done configuring MobaXterm to use an SSH key to log into our Debian VM. The next thing we want to do is to install VS Code and configure it also to use SSH in the same manner. So let's go download VS Code. I'm sure you're familiar with this step. And to quote Microsoft, the user installer, quote, is the preferred way to install VS Code on Windows, unquote. So that's what we'll do. You'll probably want the x64. Now that it's fully downloaded, go ahead and browse to wherever your computer downloaded it. And you're going to install it. Typical stuff. I like to click these Windows Explorer context menus as well. Those I find to be pretty useful. I'm going to pause the video while it goes through this install. And we have installed Visual Studio Code. Let's go ahead and click Finish with this checked to launch it. The old days you had to manually install the SSH mechanism, but VS Code kind of guides you through that now. So what we'll do is we're going to click down here, and it's going to think for a moment, and then it's going to give you some options. You're going to click SSH. It's going to auto install that extension for you. That's kind of nice. We're going to add a new host and put in your username on your Debian machine, and then your Debian machine address or MDNS address if that's available to you. In my case, the MDNS is not working at the moment, so I'm going to use the IP address. And then you do want to put it into that same folder that should look familiar that you did your SSH keygen in. Okay, it's added the host. And now we can connect to the host. And there it is. It's kind of ugly. We can make that a little prettier later. It's opening remote. Go ahead and click Linux. And it's being very secure about it. I'm going to click yes. We trust this. You can double check that yourself if you want to. There's fingerprint verification tools, but it's likely you're not interested in that at the moment, so click continue. And now with that, because we did all that SSH key configuration beforehand, you'll notice we didn't get prompted for a password because it's the same quote-unquote magic that we used with MobaXterm. So that's pretty cool. So now if we open a folder, you'll see this is looking very much like the Debian folder. There's Espresso stuff installed. So at this point, we have MobaXterm and VS Code fully configured and ready to go to facilitate our ESP-IDF development. At this point, we're ready to begin our next process, which is to ensure that VMware connects up our Espressif device. So before we begin, there's a predicating step which I forgot about, and unfortunately, I've already recorded that video part. So keep this in mind as you watch the next part. We need to install a mini-term, and the name has been slightly changed from the old mini-term, which is what you'll see me using. It'll be called PySerial mini-term. Allow me to demonstrate. We'll go over here, open up a command prompt, go to sudo mode, go apt install python 3 py serial, not PySerial, just serial. And it's going to install a few goodies. And once it's done, probably you won't be able to do mini-term, but you will be able to do PySerial mini-term. Okay. So for the upcoming part of the video, keep that in mind. Now we're going to plug in an Espressif device. I have quite a few of them here. I'm going to show you what a few of them look like. We'll start with one that I got from LilyGo. So we will plug it in. You'll see a window pop up, and it will ask you where you want to connect that device. And that's good news. VMware gives you the choice of saying, hey, you want to let your host Windows take over, or do you want me, VMware, to grab it? In this case, we want VMware to grab it because, of course, that's where our ESP-IDF development environment lives. So we'll go ahead and connect it to that virtual machine. Hit OK. So now let's make sure it's actually available. Check out your removable devices. Yep, there it is, USB JTAG serial debug unit. Go ahead and open up a terminal and run miniterm. And let's just make sure it's actually present. Excellent. Sometimes VMware gets a little confused. Check this out. This is an ESP32C3 SHAO from Seed Studio. And see, VMware just gets out of sync with itself. Unfortunately, when this happens, you'll have to reboot your entire host. Not just your guest VM, but the entire physical machine. Next up, we're going to connect up a Wemos Mini 32. Pretty much everybody's got one of these. They work pretty well, nice and cheap. So there you go. Connect it up. And it has a slightly different appearance in the terminal, but it's recognizable. You can have a look here with miniterm once again. You'll see CP2104. It might look a little different. They change them, but it'll look pretty much like that. Now here we have the dev kit. Dev kit kind of has its own personality. This future devices, this will be pretty predictable, and noteworthy is that there'll be two of them. ESP-IDF will be able to resolve which one it wants to use, but don't be thrown. That's expected with the dev kit. Now that our Espressif device is talking to our virtual machine, it's time to try flashing some code to it. We're going to keep things real basic here and just use one of Espressif's built-in Wi-Fi examples. For this exercise, we're going to use MobaXterm to SSH in. You could also log in and do all this directly from the VM, but this whole video series kind of focuses on doing it via remote tools, such as this MobaXterm SSH. So in we go with that really nifty public-private key arrangement we've already set up from previously in the video. And what we're going to do is we're going to set up our environment. So to do that, run our previously made setenv ESP32 script. If you prefer to run that export manually for whatever reason, that works fine too. We're going to go to the location in which you installed your ESP-IDF. So for mine, it's right there. And what we're going to do is we're going to change our directory to examples, Wi-Fi, then getting started, all right, and then station. So you're going to be pretty deep in there. The next thing you're going to do is you're going to type idf.py space menu config. It'll take a little bit, set itself up. All right, once we're here, you want to go down to example configuration and change this my SSID to your Wi-Fi SSID, and of course password to whatever your Wi-Fi password is. I will wait while you do that. Okay, now that you've entered your credentials, the rest of these I've never really had to change, so I don't think you will either. So we're going to quit out. We are going to save the configuration. And next up, we're going to build it. idf.py space build. Okay, the build is complete, and you will become very familiar with this whole block of text here, ending with the IDF-PY flash and the CSP tool. That's pretty much your indicator when you see this block of text here, that everything compiled and linked properly. In the event that you did get errors and you didn't see all this come up smoothly, chances are very high that something went wrong with your ESP-IDF install in the first place. I would not advise trying to hack or adjust unless you really are confident doing so. Instead, what I would do is I would reinstall ESP-IDF, because they are very thorough about getting just the right tools onto your machine. Now that we have a successful build, the last step is to flash it. So what we're going to do is we're going to type idf.py flash, and then we're going to type space monitor to also subsequently boot up the serial monitor, because we're optimistic it's going to flash properly. We want to see all its log output. And it did not find the device. If you find yourself seeing these failed to connect, could not open messages, chances are very high that your user doesn't have the right permissions to access the serial port. That's not too hard to remedy. What we'll do, we'll use pushd with a little tilde just to make this easier for you to read. I'm going to hit clear again to make it easier for you to read. You don't have to do either of those things. And then what we're going to do is we're going to type sudo user mod for user modification, -a to add, -g to add to a group. And we're going to add to the dial out group, a legacy from old modem serial port days. And then we're going to use $user, which will map directly to your username. It's a bash variable. Go ahead and put in your password. And an important step is you do need to log back out and log back in again at this point. So Control D logs out, that's the shorthand for that. Log back in. Go ahead and set up our environment again. And change your directory to where we were. Let's see if I got it into my history here. Yep. So once again, your ESP-IDF examples, Wi-Fi getting started, station. And now, once again, we'll type in idf.py space flash space monitor. I already built it, so we won't need to build it again. And this is what you want to see. This interaction with the serial port, this interaction with the serial port, all the percentages. And what we're looking for is the IP address to pop up. And there it is. And of course your password will pop up too, so make sure nobody's looking over your shoulder when you're doing this. And this is our test. This is successful. This exercises the part, and of course makes sure that the part is connecting to our Wi-Fi correctly as well, which, if you think about it, is a pretty deep test. This is the RTOS running, and your logging is all running. A lot of things are running here. By the way, if you followed my instructions exactly from the previous video, your package updater might be a little upset with you. Allow me to demonstrate. If you type in apt space update, and you see this guy down here, Yeah, we don't want that. It's not actually going to stop you, but we like to not have any visual crust in our way when we're trying to get things done. We don't want to be distracted. So let's go ahead and repair that. Go into the apt folder, and you're going to use nano because when you're using SSH and root, it doesn't always like to featherpad out. I will show you. If you try to run featherpad here, it's going to have an issue. There are ways to fix that, but the short answer is all the magic plumbing that makes the GUI run remotely gets a little bit interrupted by the root process. But not to fear, nano is a pretty easy editor. So we'll use nano to edit our configuration. Type in sources.list, and this is about the easiest edit you're ever going to make. Hit the pound sign, you're pretty much commenting out that first line. Control O to write it, Control X to get out, and now run apt update again, and you're just fine. You don't really need that CD-ROM source, and according to apt, you shouldn't use that CD-ROM source. That's how we repair that particular error. Another optional step is we can install VS Code directly in the Debian virtual machine. I like to have it both in Windows and the virtual machine because I spend a lot of time on the virtual machine as well as remoting into it, and VS Code is a great editor. So the way we do that is I prefer to use the apt mechanism. It's not necessary, and if you don't use the apt mechanism, you probably don't even need to watch this part of the video because it's pretty easy to download a deb or a tar and just install it. But if you want to go that extra mile, I recommend you do. This is how you do it. Open up a browser, and from here, what I like to do is I type in VS Code Linux, and it takes me right to the page necessary for the install commands. You'll know it when you see it because it has all these things you got to copy paste. Now sometimes that search isn't going to work out for you for whatever reason, so the canonical way to do that at the moment is you go to the VS Code page, you'll click on Docs, and then you'll click on Setup down here, scrolling down, and then from there you'll click on Linux, and that'll take you pretty much to where we were. From here, you want to scroll down past this one and grab this whole hunk of text right here. And what this is going to do is it's going to install the Microsoft keys, public keys, for apt to trust that Microsoft really is a place from which we can download and install VS Code. And I had already done this previously, so you can see these two here. You probably won't have those. At this point, we're ready to do the true install of VS Code. And that's this chunk right down here. So we'll copy that, we'll paste that in there. And there you have it. VS Code is installed. A nice bonus, I don't really recommend you do this, but you can. Go ahead and hit Control D. We're just exiting out of the root mode. You don't want to spend more time in the root mode than you have to. You can actually, from MobaXterm, you can run code. And it does work. In my experience, the performance is not very satisfying. VS Code does have a well-earned reputation for being, relatively lightweight. But when you run it remotely like this, you can see that it kind of struggles compared to some other IDEs, such as like CLion or Qt Creator or whatever. So in a pinch, you can use this, and it does work. But I do prefer to run it natively for that reason. But kind of cool that you can. Lastly, by default, Debian installs LibreOffice, and it's fine software, and I've used it on a number of occasions. But two things. First of all, it's pretty big, and second of all, we really don't use it for ESP-IDF development. At least I don't. So we're going to uninstall that. Go ahead and enter sudo mode, And you're going to go apt remove LibreOffice, type just like that, with a little asterisk at the end. It's going to uninstall a bunch of things. Then type apt auto remove. And according to the numbers we just saw, that'll save you about 400 megabytes of drive space.